Welcome everyone. Today's lesson will be on the three forms of quadratic functions. So far we've looked at the three different forms. Our factored form, which looks like this, the standard form, remember that's the one without any brackets, and then vertex form, which we're able to identify our vertex here and it has the squared outside of our bracket. So what we're going to be doing in today's lesson is how do we convert from one form to the other? Because each form can give us different characteristics or information about our parabola. So if we have standard form, how do we take that and make it look like factored form, or standard form and make it look like vertex form? So that's our goal today, is to learn some different strategies on how to convert from one form to the other. So let us get started with some examples here on converting first off from factored to standard form. So remember, factored form here has brackets and standard form does not. So expand the equation using, using FOIL, or you might just use the words distributive property, if you're familiar with that. And then we're going to simplify. So first we're going to remove the brackets, and remember, simplify means we're going to collect our like terms. We have three different expressions here that will be multiplied together. It really doesn't matter which order you do these in, but let's look. It says expand using FOIL. So your choice, whether you do this first or you bring your 3 into the bracket here. I'm going to do this first because I notice a lot of my students, this seems to be the method they like the best. So I'll have a negative 3x subtract 9 inside my bracket. Remember, if you know that you're going to be multiplying again, you have to keep this inside a bracket. Now we'll do the FOIL. Remember, you take the first terms. So I have a negative 3x squared. Then you'll take your last terms, a negative and a positive, so a negative 15x. We'll take the inside terms, negative 9x, and then our last terms for negative 45. The last part here, the simplify part. So we want to simplify this by collecting any like terms, and we notice we have two like terms, two x terms here. So we're just going to combine those together. A negative and a negative will give us a negative 24x subtract 45. So that's how we go from factored to standard. We're just removing brackets. So we can see that visually just by looking at the general equation. Our next example is converting from vertex to standard form. So once again, we're going from a form that has brackets to a form that doesn't have brackets. So we're going to expand the equation once again using FOIL. Whenever we have brackets, we want to remove them. If it's just binomials, we can use our FOIL method. Now you might be able to simplify this a little bit quicker because we notice we have a squared here. So depending on your comfort level, you might directly write this as a perfect square trinomial. I am not going to do that in the example. I'm actually going to, as we know, we can write this twice. I'm actually going to just do the FOIL like we did in the last example. So the first thing is I'm just going to bring the negative into the first bracket. And then I'm going to do the FOIL between these brackets. So I'll first multiply these for a negative x squared, negative 3x, the inside negative 3x, the last will be negative 9. Sorry, that x is a little wonky. And then I just have the add 1 at the end. Remember, once the brackets are removed, we look for like terms. So I have like terms here. And then I have like terms here as well. So I have my x terms and my constants. And we'll just combine those on the next line. So negative 3 is a negative 6, a negative 9, and 1 is negative 8. Both of these are in standard form as well, because we know the x squared will come first, then the x, then the constant, following the form that we have up here. Our next example, converting from standard to factored form. So factor the equation, so remove the common. Remember, we always common factor first, and then we're going to look to see if we either have the difference of squares or if we have a trinomial. Those are the three types of factoring that we did in a previous unit. So remember, for the common factor, it has to be common in all the terms you have in your equation. In this case, we have three terms. Remember, they're separated by addition and subtraction signs, and we want to see if there's a common factor. Well, 2, 10, and 12, we know a common factor would be 2, so we can divide each of these by 2. We look to see if there's a variable as well in each factor, but this does not have a variable, so it's not common in each of our factors, so we can't factor that out. I mean, in each of our terms. So when we divide here, we'll get x squared, add 5x, add 6. Now, once we've done the common factoring, we're going to look, is this a difference of squares or a trinomial? Remember, difference of squares is 2 terms. And we have 1, 2, 3 terms. We notice that it's in the form of trinomial factoring with our squared, the x term, and a constant. So we'll put our 2 brackets. Remember, the first in the bracket, we need the factors of 1. The end part of the bracket, we will need the factors of 6. So we really have no choice. It'll be an x here and an x here, because x times x is our x squared. Remember, we usually try and start with the factors closest together. Remember, this is a trial and error method, so you're looking to see if that will work. So we have our 2x and 3x. Remember our smiley face. And when I take 3x and I add 2x, I do get 5x. So I would be adding both of these. So this is our factored form right here. So our next example, converting from standard to vertex form. This is completing the square. Now we did do this last year, but we haven't reviewed it this year like we have as far as expanding and factoring. So there are some steps for us to follow here at the bottom of the page. So we'll be following through on these steps. So let's get started. Factor A from the first 2 terms. So I'm coming here, I know this is my A. If we look back up to the equation, right, the A is in front of the x squared. So I'm coming down here, I'm going to factor A out of both of these. So I have my A out front, then I have x squared, add 3x. Leave some space in the factor bracket, keep C, remember C is this last number, to the far right. 2, using B value, the new B value, find B divided by 2 squared. So here's our B value. So what we're doing is we're taking our B value, we're dividing it by 2, and then we're squaring it. Remember, you square the numerator, square the denominator. We're going to add and subtract that into our bracket. So that's number 3. Add and subtract whatever we find for B divided by 2 squared inside the bracket. 4. Remove the negative from the bracket by multiplying it with A. So we're going to take the negative, which is right here, and we're going to multiply it by their A value 2 to remove it from the bracket. We know we don't need this in the bracket because remember we're trying to get a perfect square trinomial inside the bracket. So this is a perfect square trinomial, the first 3 terms. Remember when we multiply this, we can actually reduce the 2 and the 4, so it'll be negative 9 over 2, add 12. Simplify the equation by factoring the perfect square trinomial. So we're first going to factor our perfect square trinomial. So remember when you factor the perfect square trinomial, we can do a little shortcut here. It works best when you have something like a fraction here. But remember, to write inside the bracket here, it's the square root of the first term, the sine of the middle term, and the square root of the last term. Then we need to just take our constant terms here, and we need to find a common denominator, which would be 2. So we have 24, subtract 9, so we would have add 15 over 2 as our final answer. So remember, when completing the square, this does not have brackets, so we're trying to introduce brackets first off, and then we know there's an a value out here, so we're looking to complete that a value, and then we get our squared and our k value here at the very end as we complete that. Now let's just try some extra practice using those steps. On the back of the page here, we have some examples to go through. So remember, the first thing we do is we're going to factor out the a. In this case, the a is just 1, but we're still going to do the other part of that step where, even though we're not factoring out a number, we're still going to create our factor bracket and put the c value at the end. Now, using our new b value right here, which is 6. So remember, this is the b value. We're going to do -6 divided by 2 squared, which will be -3 squared, which is equal to 9. Sorry, I probably should have done that over to this side. Once again, once you've done that, you're going to add this into the bracket and subtract it into the bracket. Number 4, we're going to remove this negative part by multiplying it by whatever's out front. In this case, we're just multiplying it by 1. So our next line would look like x squared minus 6x add 9. 1 times -9 will just be a -9 add 8. Now we're going to simplify our equation by factoring the perfect square trinomial. You can do the shortcut like we did at the first, but this one, since it's not a fraction, I'm just going to look at factoring it first to show you that way. So we're going to factor this. Remember, we need our factors here and our factors of 9. There's no choices here. This will just be x and x. Remember, we try the ones closest together first, so I'm going to put 3. When I multiply these together, I get a 3, and these together will be a 3. If I add them, I do get 6, but I need a negative, so it'd be a -6. And back here at the end part, I can actually combine these like terms. And when I combine those, I will get -1. Now we know if we have two things multiplied together, we can write that as a squared. So this is what our final answer would look like. Let's try another example. Once again, even though our a value here is 1, we're going to write the first step where we write our squared and our x term in the bracket, and then out here we will have our c value. Taking our b value, which is 4 this time, we're going to divide it by 2 and square it. So we will have 2 squared, which is 4. We add and subtract 4 into our bracket. We know this creates our perfect square trinomial, so we're going to take this outside the bracket by multiplying it by what's out front, and therefore our equation will now look like our perfect square trinomial in the bracket with the -4 outside the bracket. Now once again, you can factor like this, or you can just recognize that when we do that, it's the square root of the first term, the sine of the middle term, and the square root of the last term gets us our squared, and we'll collect our like terms here, and that will be a -2, sorry. So those are with a coefficient of 1. So let's go down and look at what if we, oh, sorry, we still have one more with a coefficient of 1. Sorry, I thought we were going down to negatives, but let's try this one. You could shut the video off at this point and give this one a try. and then restart the video to make sure that you're doing it correctly. So once again, we don't have a coefficient other than 1, so we're just going to write the bracket, and we're going to put our C value outside. We're going to take our B value, remember, we're going to divide it by 2 and square it, so it'll be 1 squared, which is 1. This gets added and subtracted into our factor bracket. We're going to always be taking the negative value out by multiplying it by what's on in the front of the bracket, or the A value, because this is our perfect square trinomial. Remember, perfect square trinomial is just these first 3 terms. The next step is we'll factor this. Remember, it's the square root of the first one, the sine of the middle, the square root of the last term squared. A -1 and a +9 will be 8. The next example, what if we don't have an A value of 1? This time our A value is just a negative sign. So we have to divide out negative of the first 2 terms. So I'm going to put the negative in front. Remember, we're really just dividing these two by -1. So I'll have x squared subtract 12x. And we'll write our C term here at the end. We take the B term, we divide it by 2, and we square it. So we'll have -6 squared, which is 36. We're going to add that into our bracket and subtract it. Here's our perfect square trinomial. So we'll take this to the outside. And really this time it's just going to change the sign of 36 to now be a positive. We're going to combine these like terms, remember, and we're going to write square root of x, the sine of the middle term, the square root of the last term squared, add 38. So what happens if we don't have a coefficient of just 1 or -1? Same steps. As you can see, we're doing the same steps each time. It's just that we might be working with larger or smaller values. So once again, we're going to take our first 2 terms and we're going to divide out this coefficient A. We divide it out of the first term, we get x squared. When it divides out of 8, so a positive and a negative will give me a negative here. 8 divided by 4 is 2. Write the C term at the end. We'll take our B, and we'll divide it by 2 and square it. So we get -1 squared, which is equal to 1. We add it in the bracket, subtract it in the bracket. Once again, this is the perfect square trinomial, so we'll take this to the outside. So we have -4 x squared minus 2x, add 1 for the perfect square trinomial. A negative and a negative will be a +4, add 3. Now we need to write our squared, square root of the first term, sine of the middle term, square root of the last term, and combine our like terms here for 7. Remember, anytime you can just shut off the video and try the examples before I do them here, just as practice on your own. So our last one, we take our first 2 terms. We're going to divide out the A value. This time we're dividing out 3 of both of these terms. We keep a big space and put our C at the end. Take our B value and square it. 4, so we're going to add 4 into the bracket and subtract 4 into the bracket. Now we just need the perfect square trinomial in the bracket, so we'll rewrite that. And we'll take the negative term outside the bracket, so -12 add 2. Writing it as a perfect square, as a factor, so square root, sine, square root, squared, and we'll combine these. A -12 and a +2 is -10. So that is our lesson today. First off, just knowing how to convert from one to the form to the other, and a little bit of extra practice for completing the square.